Better Fit e-learning platform. My name is Edwin. Now, I think last week we concluded a particular topic, which is the calculation we did in other past topics. So the one I left behind was the one I concluded last 2 weeks. So now, for this week, this particular class is for SS2. This is the first topic for the 10, and a revision class for SS3. And the topic is sulfur and its compounds. Now, first, sulfur and its compounds is a very wide, topic. That does not mean you shouldn't read wide, but there are some main points that you need to bring out, that you need to digest. Not that everything is not important there, but you have to bring out the main points that you need. Those important points that examination body can set questions from. So first, we have to talk about the extraction of what? Sulfur. The extraction of sulfur is basically by the process called Fratch process. Fratch process. I repeat, the extraction of sulfur is based on Fratch process. So the Fratch process actually entails that you bore a hole, you drill a hole straight down to the earth crust, where you will now find what we call sulfur bed. That sulfur bed, down to the earth crust, you take what? A pipe, a very long pipe, down to the earth crust until it finally gets to what? The sulfur bed. Now, after that, what next? You have to pour in a superheated water. A superheated water that is at the temperature of 170 degrees Celsius at a pressure of 10 atmosphere. So now, after that, what you are going to get at the end of the day is what? Sulfur. That sulfur that you are going to collect at the end of the day, which is the primary target, is basically what? Pure. By what percentage? It is 99.5% pure. It is 99.5% what? Pure. That is to tell you how pure the sulfur is. Which simply means that it contains just less or no impurities. Now, the next step is to talk about the allotropes of what? Sulfur. So allotropes of sulfur, the main two allotropic forms of what? Crystalline sulfur, they are just what? Rhombic sulfur and what? Monoclinic sulfur. Another name for monoclinic sulfur is prismatic sulfur. So the rhombic sulfur is also called what? The alpha sulfur, and the monoclinic sulfur or prismatic what? Sulfur is also called what? Beta what? Sulfur. But other forms of amorphous sulfur, they are other what? Plastic sulfur. So now, let's talk about the rhombic sulfur. The rhombic sulfur is actually what? One type of what? Sulfur that is very stable. But not just stable, but please mark my words, it is very stable below the temperature of 96 degrees Celsius. I repeat, I said rhombic sulfur, which is the first crystalline form of sulfur, is very much stable, but below the temperature of 76 degrees Celsius. Don't forget, below the temperature of 96 degree Celsius. Now, it is octahedral in shape. Yes, it is true. It is octahedral in shape and also yellowish in color. Then, the second type of crystalline form of sulfur is monoclinic sulfur. Like I said before, another name, prismatic sulfur. It's another type of sulfur too. It's also stable, just like the rhombic sulfur. So monoclinic sulfur is also what? Stable, but the stability must be between the temperature of between 96 degrees Celsius to 119 degrees Celsius. Is there? So what shape does this monoclinic or prismatic sulfur have? It has a needle shape. Yes. It has what? A needle shape. I think this is one of the examination questions too. Something can come up like this. Which one of these shape has a monoclinic what? Sulfur? You tell them it's what? Needle-like what? Shape. It looks like what? Needle, very tiny. So compared to what? Rhombic sulfur, that is what? Octahedral in shape. So with this now, rhombic sulfur and monoclinic sulfur, you should be able to differentiate their shape and their what? The temperature with which they are what? stable and all that. So now, from this part now, this is the transformation of what? Rhombic sulfur to what? Prismatic sulfur or monoclinic sulfur, or rather, back again from prismatic sulfur or monoclinic sulfur back to what? Rhombic sulfur. So this is the full summary of what happens between rhombic sulfur and what? Monoclinic sulfur. So from rhombic sulfur, it's very much stable below what? The temperature of 96 degrees, between 96 to what? 119 degrees Celsius. So while coming back, you have the return there, 96 degrees what? Celsius. Now, after that, we move over to the other side. Now, sulfur, as we all know, is actually what? A non-metal, just like oxygen. The most pronounced elements in that group 6 is sulfur and what? Oxygen. Now, let's talk about sulfur now. Sulfur is a non-metal, just like oxygen. It's having an atomic number of what? 16. The atomic number is simply the number of protons in an atom of what? An element. Since that is the number of protons, because it is neutral, we say that the number of protons equals the number of what? Electrons. Which simply means that we also have what? 16 protons and 16 what? Electrons. Now, how do we now distribute these electrons into the various shares of an atom of sulfur? Now, we know that the first share is going to begin with what? 2. The second share will take what? 8. And the last share will take what? 6. So sulfur has what? 3 shares. 2, 8, 6. Now, the valence electrons at the atomic share actually what? Tells you the group a particular element belongs to. That is to tell you that sulfur belongs to what? Because it has 6 valence electrons, it means that sulfur belongs to what? Group 6. How many shares do we have here? 1, 2, 3. It means that sulfur belongs to what? Period 3. So the number of shares denotes what? The period the particular element belongs to. So group 6 and what? Period 3. Now, first, what is now the electronic configuration? Since we now know the distribution, now this is how we are going to distribute the electrons into the various shares of an atom of what? Sulfur. How do we now write the electronic configuration of what? Sulfur. First, sulfur, the first share will take 2. That is that. This one is gone. The second share will go to the 2x orbital, which is 2. This one is gone. Remaining what? 6. Balance 6. The next one will go to what? 2p what? 6. This one is what? Gone. What is now left is what? 6. So the next share will go to what? 3. Since we have 2x, we go to what? 3x 2. This one is what? Gone. Balancing what? 4. The next one will go to this 2p. The next one will go for 3p orbital, which is what? 4. So let's calculate the number of electrons together. Let's see whether it will amount to what? 16. 2 plus 2 is what? 4. Plus 6 is what? 10. 10 plus 2 is what? 12. 12 plus 4 is what? 16, which is actually what? The atomic number of what? Sulfur. So this is the electronic configuration of what? Sulfur with the atomic number 16. Hope you are getting what I'm saying. That is that. Now, let's talk about the physical properties of what? The physical properties of sulfur. Sulfur has so many physical what? Properties. Sulfur has so many physical properties and so many chemical properties. So let's start with the first one, physical properties. Now the first one is that sulfur is a yellow solid. Yes, it is true. Sulfur is what? A yellow solid. Now the second one is sulfur is very much insoluble. Sulfur is insoluble in water, but it can dissolve in carbon 4 sulfide. CS2, yes, it's there. It can dissolve in what? Carbon 4 what? Sulfide. But it is insoluble in water, but it is soluble, or it can dissolve in carbon 4 sulfide. Which I've already told you before that sulfur is a non-metal. Because it's a non-metal, so sulfur is a bad conductor of what? Heat. And again, the density of sulfur depends on the allotropic form of sulfur, whether it is rhombic, whether it is monoclinic or even prismatic, or whether it is even what? Plastic, depending on what? The allotropic form of what? Sulfur. That is how to determine the density of what? Sulfur. Now, the next step is to move over to the chemical properties of what? Sulfur. Chemical proper chemical properties. So the first one we are going to look at here is that, I told you before that sulfur is a non-metal and it has 6 valence electrons in the outermost shell, and it has the ability of what? Combining or reacting with what? A metal. Let's say for example group 1 metals or group 2 what? Metal. Yes, sulfur can react with them through the process called what? Electrovalent what? Combination, which involves the transfer of electron from a metal to non-metal. At the end of the day, an octet stability is what? Achieved. An octet what? Stability is what? Achieved. So that's the electrovalent combination of between what? Sulfur and what? Group 1 or group 2 what? Metals. Now, the first one is what? This, let's say sulfur combining with, sulfur combining with what? A metal here. Let's take the solid plus iron. Let's take the first one here. Now, when sulfur combines with what? A metal here, iron, both in solid state, what we are going to get is what? Iron sulfide, which is what? Also what? A solid. So this reaction with what? Metals. I'm dealing with what? The reaction of metals now. Sulfur reacting with what? Metals to form what? Iron sulfide. So that is the first one. So the second one, let's also move on to say, okay, let's take for example now copper, again reacting with what? Sulfur in solid state again to form this solid again to form copper 1 what? Sulfide. So copper reacting with what? Sulfur to form what? Copper 1 sulfide. Now you can see the reaction of sulfur with what? Metals. So all these compounds, they are what? Electrovalent what? Compounds. They are what? Electrovalent compounds. Why? Because it's between what? A metal here is between what? Metals and what? Sulfur to form what? Electrovalent compound. And these compounds that are formed, they are what? Ionic in nature. By the time they undergo, yes, they are ionic in nature. Then for with the non-metals, what happens with the non-metals? Yes, sulfur also reacts with what? Non-metals too. At the end of the day, it forms what? A covalent what? Compounds. By simply, in this case now, it does not involve what? The transfer of electron from a metal to what? Non-metal. But instead, since there are two non-metals involved, let's say for example now with oxygen or with hydrogen reacting with what? Sulfur, a non-metal, they are all non-metals. That's one thing about what? Covalent what? Compounds. So each time that sulfur reacts with non-metals like oxygen and what? Hydrogen, it forms an electrovalent, it forms what? A covalent what? Compounds, which actually involves the sharing of what? Pair of electrons. The sharing of what? Pair of electrons. Now the pair comes from oxygen and also comes from sulfur. Now with hydrogen, the pair also comes from hydrogen and also comes from sulfur. At the end of the day, they react together during what? Covalent what? Combination to form a covalent compounds because they involve what? The sharing of what? Pair of electrons. Let's check that again. B, the reaction with what? Non-metals. Let's take for example now oxygen, sulfur in solid state reacting without oxygen, gaseous state. At the end of the day, it forms what? Sulfur 4 what? Oxide. It's a gas. It forms what? Sulfur 4 oxide. You can see that sulfur, reacting with what? Oxygen to form what? Sulfur 4 oxide. Let's also check it again with hydrogen. With hydrogen, sulfur combining with hydrogen here, gas. At the end of the day, what happens? It forms what? Hydrogen sulfide gas. It forms hydrogen sulfide what? Gas. So I believe, let's see whether all these equations are balanced. From this place now, from the first one here, copper is what? 2. To balance it, we have to put 2 here to make it 2 copper here, 1 sulfur and 1 sulfur. It is balanced. Same thing with this one is also what? Balanced. Sulfur 1 here, sulfur 1 here. Oxygen is 2, oxygen is 2. Now here, sulfur is 1, hydrogen here is 2. Hydrogen here is 2. Yes, it forms what? I think that one is balanced too. It forms hydrogen sulfide what? Gas. Now later on, when we are dealing with the gases or compounds of what? Sulfur, you will now know what this hydrogen sulfide gas can do. What this hydrogen sulfide gas can do, the smell, the reactions and all that, so they will get. So now first, And foremost, I think we are through with the reaction with metals, and again we are through with the reaction with non-metals like oxygen and hydrogen. Good. Now the next stage is to move over to uses of what? Sulfur. What is sulfur used for? Sulfur has so many uses. So many you can think of. Now uses of sulfur. The first one is that sulfur is used for making what? Sulfur 4 oxide. Yeah, thank you. You see here. Sulfur is used in making what? Sulfur 4 what? Oxide. That's the first one. And the sulfur 4 oxide is needed for the production of what? Tetraoxo sulfur 6 what? Acid. I said sulfur is used for making what? Sulfur 4 oxide. And at the end of the day, the same sulfur 4 oxide can be used to make what? Tetraoxo sulfur 6 what? Acid. Yes. Now the second one is, it is also used for what? Vulcanization of what? Rubber. Yes. For those people, those vulcanizers along the road, at times when you see them trying to patch up their tires, you know, you find out that there's something that they normally add. It is what? Yellowish in nature. So it is sulfur that they normally want to add. It is needed in the vulcanization of what? Rubber. I repeat, sulfur is used for the vulcanization of what? Rubber. The third use is sulfur and some of its products are also used for, they are used as what? Fungicides and what? Insecticide for spraying crops. Yes, I think that is an agricultural use of sulfur. Then the last one is that sulfur is also used for the production of what? Bleaching agents. Yes. Bleaching agent is also, yes, sulfur is used for the production of what? Bleaching agent. Not only that, carbon 4 sulfide, dyes, and even some what? Gunpowders. Please do not think of this. I know you are a chemist. Please don't think of this. So please, sulfur is also used for the production of what? Gunpowder. The same thing with what? Fireworks. And lastly, matches. For those of you who have always been using your match to light up your gas or your stove, so that is how it is. So these are important uses of what? Selected important uses of what? Sulfur. So now, maybe in our next subsequent classes, we are going to be dealing with what? The compounds of what? Being formed by sulfur. Where we'll be talking about the gases and other compounds like tetraoxo sulfur 6 acid, hydrogen sulfide, sulfur 4 oxide, sulfur 6 oxide, and so on and so forth in our subsequent classes as time goes on. So I believe you have digested this particular topic, well brief, and the main points being selected out. These are the things you actually need to digest to prepare you for your exam. So you don't need to read everything because the topic is very wide. So I have to take my time to bring out these points to enable you digest it very well. So I will see you same time next week on this same platform. From me, remain blessed. Thank you.